Okay, geometry fans, our topic for today, Notes 4-4, proving triangles congruent, and we're going to use what's called two-column proofs. So before we start, let me give you your joke of the day. What do you call a sleeping dinosaur? And the answer is a dinosaur. Okay, that was pretty bad. Before we start, okay, the thing about doing a proof is it's like a set of directions. You are explaining to somebody how to get from point A to point B, but you have to justify and explain why. Why am I allowed to do this? Why am I allowed to say this? Why can I say these are congruent? Why can I say these have something in common? So it's like a step-by-step set of directions. So the strategies for doing two-column proofs. Step one is the most important, and that's to read and understand the given and the proved statements. Where are you starting? Where are you trying to get to? Okay, again, if I'm traveling from point A to point B, I need to understand where I'm starting, and I need to know where I'm trying to go to so that I know when to stop when I get there. The second thing we want to do is we want to draw and label the picture. But don't label until it's written in your proof. Okay, we'll get to that in a second. And the third thing we have to do is we have to look for relationships. We're going to be proving a lot of things congruent. So that means we have to look for relationships that let us say that things are congruent. So for example, okay, you have a lot of space down here. Anytime two lines cross, we always know vertical angles are congruent. And so if you see this situation, you can say that the angles are congruent, and the reason is because vertical angles are always congruent. So it's not just saying that these are congruent, it's also explaining why. What's the reason? Well, we have a theorem, we have a rule that says vertical angles are always congruent. When you have parallel lines, you have certain relationships that happen with parallel lines. One of the most common, when we have, okay, I'll put the arrows here on the top and the bottom. That means the lines are parallel. If you see that letter Z, that Z shape right there, the two angles that get created here and here have to be congruent. Now the official reason, so it's a letter Z, but that's not the reason. The reason is that for parallel lines, this is how I'm going to write it. Parallel lines imply alternate interior, INT, alternate interior angles are congruent. That's what that's called. Those two angles are called alternate interior. So when the lines are parallel, I can say that these have to be congruent. Drawing a similar picture here, anytime two triangles have a side, if they share a common side, that would be congruent. I can say, I always label that with an X. I can say that that side is congruent to itself. We call it a common side. Both triangles share that side. The reason is called the reflexive property. So again, I have to explain, why am I allowed to say that's congruent to itself? Because it's reflexive. Certain words give you information. For example, if we, let's say AC, B, D, here's point E. If you're told that segment AC bisects BD, segment AC bisects segment BD. Now that means that segment BD gets cut in half. Bisect means to cut in half. Well, if BD gets bisected, then I can say, first of all, E is the midpoint of BD, but I can conclude, therefore, that segment BE is congruent to segment DE. And the reason is because of the word bisect. It's a segment bisector, okay? If I have a situation where they tell us that, let's say, this is point D. Let's say D is the midpoint. D is midpoint of segment AB. Well, if D is a midpoint, then that tells me that these two segments have to be congruent. So segment AD is congruent to segment BD, or DB. Okay, so certain words, bisect gives you congruence. Midpoint leads to congruence. Perpendicular. Perpendicular means you have 90-degree angles. Well, so perpendicular means we have right angles, but right angles are always congruent. So right angles mean congruence. Okay, so these words, these relationships give you information that allows you to say that things are congruent. Okay, so we're going to do a couple examples of proofs. The two columns here, we have statements on the left. That's where we say what's true. And then the reasons are why we can say that they're true. All right, so number one here, we have this picture of two triangles. Now we are given information. Those are things that they're telling us at the beginning that are true. Segment AB is congruent to segment AD. AB and AD are congruent. And then segment BC is congruent to segment DC. So BC and DC are congruent. Prove. Given is where you start. Prove is where you finish. So what are we trying to prove? That triangle BCA, that this triangle is congruent to triangle DCA. The first step, the first statement is always given. So statement one, so I'm going to write down a 1 here, and I am just going to copy the given information. Segment AB is congruent to segment AD, and segment BC is congruent to segment DC. Now, what's the reason why I can say that? It's given to us. The problem tells us that's true, okay? Now, once we have that, once we write it down in our columns, I am now going to label that in the picture. Segment AB is congruent to segment AD. Segment BC, now I'm going to put 2 marks because that's different from these. BC is congruent to DC. What are we trying to show? What are we trying to prove? We want to prove that these two triangles are congruent. Well, to prove triangle congruence, you need to have 3 pieces of congruent information. We have 1 pair of sides, we have 2 pairs of sides. We need a 3rd pair of things that are congruent. Now notice that both triangles have side AC. Now we can say that segment AC is congruent to itself. There's the 3rd piece of information. So step 2, statement 2, AC, segment AC is congruent to segment AC. The reason we can say that, okay, we had that up here, that's called the reflexive property. It's a common side, but the reason is called the reflexive property. So reason 2 is reflexive property. Okay, now, to show the triangles are congruent, we need to have 3 pieces of congruent information. We do. If I look at the top triangle here, we have, this is a side, this is a side, and this is a side. So our last step, we're done. Our last step is the proof statement. We have enough information to say that triangle BCA is congruent to triangle DCA, and the reason is side, side, side. Side, side, side. When you have 3 pieces of information, normally that's enough to say that the triangles are congruent. Now, just as a review, the options you have for showing congruent triangles, you have side, 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 you have side, angle, side, we have angle, side, angle, 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 side, and we also have hypotenuse leg, which is a special case of angle, side, side, which normally doesn't work. Okay, so this is a proof. This is it. Why could I say this? Because of a reflexive property. Why are the triangles congruent? Side, side, side. Once I get to this, I'm done. Okay, so that's it for number 1. let's take number 2. So number 2, given, so I'm going to put that in our statements first. Angle 2 is congruent to angle 3, and also angle B is congruent to angle D. So reason number 1, I'm always going to put the reasons right across from, I'm going to number them so they're kind of on the same line for that. The reason we can say that is it's given to us. So now let's take our picture and let's label that. Angle 2 is congruent to angle 3. Angle B is congruent to angle D. Now, one of the things you have to be careful about is assuming that things are congruent just because they look congruent. For example, you might look at DC and say that that looks congruent to AB. Unfortunately, we don't know that, not yet. DA looks congruent to CB, but we don't know that yet. So we can't assume things are congruent. We can only go by the way the picture is drawn or what we're told. Now what we're trying to prove actually is that segment AB, that's the bottom, is congruent to CD. So notice that this is different because in the first problem we were asked to prove triangles congruent. These are corresponding parts. Those are parts. Now here's the thing, before you can say that the parts are congruent, you first have to show that the triangles are congruent. So what we're going to have to show is that this triangle DCA and this triangle BAC, that those are congruent. If you can show the triangles congruent, and that would be because of side, 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 or one of those postulates, if we can show that, then the last thing would be that the parts are congruent, and the reason would be CPCTC. Corresponding parts of congruent triangles are congruent. Okay, so that may seem a little confusing, so let's keep going here with our proof. Right now, I see 2 congruent statements that we've put in the proof. Looking at the picture, there's one other thing we can say. We have this side in the middle here that both triangles share. That's a common side. So just like in the previous proof, segment AC is congruent to itself. And the reason is reflexive. You don't need to put property, you can just say reflexive. Now, I see 3 things that we've written into our proof, 3 congruences, and I see 3 in the picture in each triangle. So let's do this. Let's just look at the triangle on top. I see an angle, and I see a side. Now the side is not between the 2 angles. The included side would be here. We don't know that yet. Okay, so what we can say is that triangle, now I'm going to say DCA, it doesn't matter how I list the first triangle as long as I match up the second one. D corresponds to B, so triangle DCA would be triangle B, and it would be BAC. So DCA is 2 arcs, 1 arc, nothing. 2 arcs, 1 arc, that's A, and then C. The reason for that is that's angle, side. So if the triangles are congruent, then that means that all the other corresponding parts have to be congruent. Okay, so I can say now that DA and CB are congruent because the triangles themselves are congruent. Now what we want to say here, the last step, is that segment AB is congruent to segment CD. Why are we allowed to say that the corresponding parts are congruent? Because we know that the triangles are congruent. And that's called CPCTC. That's the abbreviation. Okay? So the logic in this, you can't say the parts are congruent until you know that the triangles are congruent. We can't say the triangles are congruent until we have enough information to be able to use one of our postulates like angle, side. Okay, so that's the end of part 1. Go ahead and turn this over and start part 2.